I think one of the most single difficult topics in math to learn and teach is this notion of domain. Y'all, every function has a domain, and it's where the function lives. It's the set of all possible inputs to the function. And we're using x as the input. So you're trying to find ranges of x where the function is defined. You don't get a divide by 0, or in this case, you don't get a complex number. Now, notice I did say find all x a member of the real numbers. We're not interested in any complex solutions to this that may exist. Often in high school or college, even they'll just say find the domain, and it's understood it's a real valued function. I'm just being explicit here. Now, there's two concerns. You got to guard against a negative radicand, or this piece right here. That piece, that's the radicand. And if it's negative, that would result in imaginary solutions and overall complex solutions, right? So we have to force this radicand to be strictly greater than or equal to 0. The square root of 0 is just fine, okay? But the square root of a negative number would introduce complex solutions. So we're excluding those because it's x a member of R, right? Now, this is very quick to solve. We learned that it's all x greater than or equal to 1 minus 1/3. Okay, just subtract 1 and divide by 3, and you get this result right here. Now, this is a range of numbers, folks. So again, this is going to be part of your domain, or it's going to have a lot to do with the outcome of what the domain is actually going to be. Now, another concern is having a division by 0. And if this whole object was 0, this object right here, and it looks like I left out, that probably should be 2 there. That should be raised to the second power right there. It really doesn't make any difference because 0 raised to the second power is 0, but just to be precise. So we have to avoid division by 0. Nobody's ever made any sense out of dividing by 0. So we have to avoid division by 0, and doing things by inspection is just fine. At this level, it really is at any level. You know that here's a 4 right here, and for this to be equal to 0, this entire object has to be equal to 4. Okay, that means this entire object, that means this radicand would have to be equal to 16. The square root of 16 is 4, right? That happens exactly when x is equal to 5, okay? So now, this notation I'm using here is slightly in abuse. I'm trying to indicate that we are dealing with sets. So it's the set of all x that are greater than or equal to minus 1/3. It's understood we're talking about real numbers, all right? Now, notice that this solution of 5, and this is a point of confusion on a lot of people, it costs people points on tests. This is the solution to the equation that would induce a division by 0. This would, if 5 is right here, see, you get the square root of 16, which is 4. 4 minus 4 is 0. And you'd be dividing by 0, right? So we have to exclude. That's why we have the negated equality sign right here, okay? So it's the set of all x greater than or equal to minus 1/3 intersected. We're using set intersection notation. The intersection means all the elements that are common to both sets, all right? Well, the only thing you got to worry about in this set is that you're not equal to 5. Any other number other than 5 is going to be a member of this set. So this is virtually like saying the entire real numbers. So when you intersect this set with this set, it's kind of a punctured interval here. Notice we have to exclude 5 here. Y'all, the parentheses here means to exclude, okay? The parentheses mean to exclude. The brackets here, the square brackets, means to include. So this is the answer to the question. That is the domain to the function, folks. Hope you guys enjoyed. Let me know if I can do anything different to help you.